to join.
Yes, sir, you can.
Okay, I think it is towards the end now. All the students might be exhausted by now.
I started the recording. You can start.
Yeah, that is what we'll do. We'll start. At least you can switch on the recording. I think recording is on. Okay, so I'll start the class. Whoever can join, whoever joins, they will come. No issue. Hello all, I welcome you to the third lecture, that is for gears, right? So we'll be covering up gears in detail in 2 hours, whatever is possible. Whatever is possible. So let's start. So just hold on, I will share the screen once again. Okay. So here we go with gears. Okay. So this is an important chapter with respect to any exam. With respect to any exam. So we are not going to cover it with respect to design point of view. We are going to cover it with respect to analysis of the kinematics of gear. We're going to cover it in the with respective of kinematic analysis. Okay, so let us start. Let us exactly first see what are gears and why we use gears, the basics. So there are basically 3 functions of gears: to transmit torque, to reduce speed, and to magnify torque, right? So transmit torque, how? So there are suppose 2 shafts. One of the shaft is having the motor attached to it. Suppose one of the shafts have a motor attached to it, right? So the shaft is rotating. Now you need to transfer this power to another shaft. Let me see, you need to transfer this power to another shaft which is parallel to this shaft, or even if it is non-parallel, right? So what we can do is we can connect a gear system. We can use the gear system here, right? We can use a gear system here to connect these two shafts. So what we have done, we have transmitted the torque from one shaft to the other. We have transmitted torque to the from one shaft to the other. Similarly, we can reduce speed. How exactly we are going to reduce speed? If you know the in most of the uh, engines or the turbines, right? For example, your IC engine, right? For example, your gas turbines, or even the um, what we call our steam turbines, right? The original speed of these machines are very high, which is practically not feasible to use. This is practically not feasible to use, right? So we have a gearbox in place. What does the gearbox do? It actually reduces the speed to the extent that is required, right? Similarly, we can also magnify torque. I'll take the simple example of a vehicle, be it a 4-wheeler or be it a 2-wheeler with gear. So if you have ever happened to start drive a 2-wheeler or 4-wheeler, right? 2-wheeler with gear, 4-wheeler with gear, right? Nowadays we know there are gearless automatic transmission is also available, but what we are talking about is the one with gears, right? So all of you must have felt that you always need to start your vehicle with gear number 1, right? So what does it do in gear number 1? In gear number 1, it reduces the speed. The speed will be low, but it magnifies the torque. Right? So the starting torque required is always high, right? Once the vehicle comes into some momentum, after that the required torque is less, so we can shift onto higher gears. Okay, So these are the three main functions of a gear: to transmit torque, to reduce speed, and to magnify torque. Right? Okay, I'll not be able to give you many examples, many details, right, in a 2-hour lecture. Generally, we cover this class for gate in 5 hours, right, 5+ hours. It goes to 6 hours also, right? But we have to condense all the topics with respect to your HCL exam, right? And you have to learn it in 2 hours. Okay, fine. So now gears are also known as positive drives. They don't have slip, right? They don't have slip in them. So all the drives who does not permit any slip are known as positive drives, right? But there are drives where slip is possible. For example, belt drive, rope drives. These are called negative drives. So you have to remember, gear is a positive drive, right? And there are other drives like belt drive, rose drive, where slip is possible, are known as negative drives. Okay, let us now go to the basic funda in a gear, right? So initially, when the gears were not there, people used to use friction wheels. So there will be two wheels, right? So a lot of friction are generated by putting friction lining here, right? And and they will be pressed against each other. Okay, they will be pressed against each other because so that the normal reaction developed at this point is very high and the resulting friction is very high. So because of the friction, if one wheel moves, right, if the driver moves, so what will happen? The driven wheel also move, right? So a very interesting point to note here is if you see the common point, if there is no slip, right? Suppose there is no slip, considering no slip, considering no slip, right? Suppose I'm considering no slip. So in that case, right, this point, right, this point can be considered. This is a common point. I can say this is a common point, right? The common point can be considered on the wheel 1 or on the wheel 2. This is a common point, right? This is a common point. It can be considered in wheel 1 or wheel 2. So if it is a common point, it will have a common velocity, right? It will have a single velocity, right? So if I say V, I can say V is equal to omega 1 R1 if the radius of the first wheel is R1, radius of the second wheel is say R2. This can also be written as omega 2 R2. This can also be written as omega 2 R2, right? Because it's common point. So if you see from this relationship, if you see from this relationship, we can say that this implies omega 1 by omega 2 is equal to R2 by R1, and since the radius are equal, so we can say it is constant. So this is a basic property of any positive drive, right? And especially gears, right, that the angular velocity ratio should remain constant. Angular velocity ratio should remain constant. If not, what will happen? If not, there will be slips possible. If not, then there will be slip possible. And if there is slip, we will not be able to use it in precision machinery, right? For example, our vehicle, our cars, right? So these are all very highly precise mechanisms in place, right? In a vehicle, in a car, highly precise mechanisms are placed. We cannot use negative drives or drives which have slip in them, right? That will be a problem, right? So that is why wherever required, the transmission system, right? What we use gears. But the problem with the friction wheel is that at very high speed and when the power transmission is high, right, and the speed is high, there will be some slip, right? At high speed and high power, some slip will occur, right? So that is why the necessity of projections instead of friction lining was felt. Projections instead of friction lining was felt, and there was the birth of the gear. There was the birth of gear. So you can see in place of the friction, what we have used here, is projections, right? Projections. These are known as gear tooth. These are all known as gear tooth. So they will mess with each other. So in this case, there is no slip possible, right? 0% slip, be it high power or low power. even at high speed or and high power. High speed and high power transmission. So let us now have some detail of parallel shafts, right? Sorry, let us have some, let us get into some classification of gears, right? We are getting into classification of gears. Classification of gears. We are getting into classification of gears. So how we can classify gears, right? So this, the first type of classification is based on the types of shaft. Or you can say arrangement of the two shafts, because when we are using gears, what the gears will do, the gears will transfer power from one shaft to the other, right? What will gears do? The gears will transfer power from one shaft to the other, right? So on the basis of the how the shafts are arranged, on the basis of how the shafts are arranged, we can classify gears, and that is what exactly we are going to study right now, right? The first, if the shafts are parallel, if the shafts are parallel to each other. So if the shafts are parallel to each other, pure rolling can be transmitted between two cylindrical surfaces, right? Pure rolling can be transmitted between two cylindrical surfaces. So if two cylindrical surfaces are in contact with each other, we can actually transmit pure rolling between them, right? Right. So what we need to do is, instead of just the cylindrical surface, right, we will form, will take a part of the cylindrical surface, will not take the whole cylindrical surface, the whole cylinder. Instead, we'll take a part of the cylinder, we'll take just a part of the cylinder, and what we'll do, we will make teeth. We will make teeth on the cylinder. We will make teeth on the cylinder. We'll make teeth on the cylinder, right? So this is how we are going to do, right? Now, on the basis of the how the teeth are made, right, if the teeth are parallel to the axis of rotation, the teeth that are made on the cylinder are parallel to the axis of rotation, it will be known as spur gear. So this kind of classifications are being asked. What is a spur gear, right? They will give four options, or which of the following gears have the teeth parallel to the axis of rotation. Will be given four options: spur gear, helical gear, herringbone gear, or bevel gear, right? So you should know the different classifications, right? So you can see these are the two shafts. You can see these are two shafts. This is one shaft. This is one shaft. Sorry. This is one shaft. And this is the other shaft, right? These are two different shafts, right? Both the shafts are parallel to each other. Both the shafts are parallel to each other. And if you see the teeth, even if you see the teeth are also parallel to the axis of rotation. So this is the axis of rotation. So you can see the teeth are parallel to the axis of rotation. Teeth are parallel to the axis of rotation. This is gear number one, let me say, and this is gear number two. This is gear number two. Okay. But these gears could not survive for very long. These gears could not survive for very long because of the problem of high impact stresses. Impact stresses. Because of sudden engagement and disengagement. Because of sudden engagement and disengagement, right? So can be used only for low power transmission. Because of impact stresses, what will happen? The gear tooths will fail, and if the gear tooths fail, hey Praveen, I hope you can hear my voice. Very nice. So we are doing classification of gears. We are seeing different classification of gears, right? So we are talking about spar gears. So spar gears are gears which have their teeth parallel to the axis of rotation. Which have their teeth parallel to the axis of rotation. Okay. So, but these gears have very high impact stresses. right? Because of sudden engagement and disengagement. Because of sudden engagement and disengagement. And because of this, the impact stresses, right? The gear tooths fail very easily, right? Very frequently. So these are used only for, even if you see spur gear, you'll see them only for low speed and low power transmission. Low power transmission, right? And there is one good thing about spur gear is there is no axial stress. No axial stress. You'll get to understand about no axial stress in a short while, right? In a short while, you get to understand what exactly do I mean by no axial stress. The second type of gear are the helical gears, right? Helical gears. So what we are discussing here, that the shafts, first of all, right? Parallel shafts, gears that will be mounted on parallel shafts. If the two shafts that you are using are parallel to each other, if the two shafts we are using are parallel to each other, and we are using two gears here. Let me say this is gear number 1, and let me say this is gear number 2. Let me say this is gear number 2. So we are using two gears here, right? So if the shafts are parallel, what are the different types of gears we are going to use? We are going to use spur gear or helical gear. So what is spur gear? Spur gears are gears where the teeth of the gears are arranged parallel to the shaft of rotation. And what are helical gears? Helical gears are gears where the teeth of the shafts are arranged, where the teeth of the shafts are arranged at an angle to the teeth of the gears are arranged at an angle to the axis of rotation. So this is the axis of rotation. This is the axis of rotation, right? So you can see the teeth are arranged at some angle. The teeth are arranged at some angle, right? So because why are the teeth arranged some at angle? Because this eliminates the impact stresses. Or simply I'll put it down as no impact stresses. No impact stress. But there is a problem here also. What is the problem? The force that will be applied on the gears will be in this direction, because the force will be perpendicular to the teeth. The force will be perpendicular to the teeth. So if you resolve this, there will be two forces. There will be two forces, F radial and F axial. F radial and F axial. So the F radial is definitely helping the gear to turn useful, or you can simply say useful. The F radial is helping the gear to turn. It is helping to transmit the torque, but FA is harmful. Why? Because it is putting unnecessary pressure on the bearings. It is not causing any help. Instead, it is putting unnecessary pressure on the bearings, and which will lead to earlier failure of the bearings. So here we have axial force. Axial force. Here we have axial force. So same problem was not there in spur gears because the teeth are parallel. The forces will be perpendicular to the shaft. So it was radial. Right? The only force present is radial, but yes, in helical gears there will be axial force. So no impact stresses, definitely good. High power transmission. We can use it for high power and speed, but there is again a problem, that is the axial force, right? For this reason, we have created double helical gear. For this reason, we have created double helical gear. So what is the benefit of double helical gear? If you consider a double helical gear, right? So you'll have teeth of teeth aligned in two different directions. So what is the benefit of this? The benefit of this is the normal force. There will be two axial force, FA means, what I mean to say, when you resolve this, the forces will be normal. Forces on gear 2 will always be normal, right? But if you resolve this force, there will be FA, in this direction, Fr. Again, if you resolve this force, there will be Fa in this direction and Fr, right? Fr will get added up, Fa will get cancelled, right? So what will happen? There is no axial load, no axial load. So this is one of the most used gears. This is one of the most used gears, right? But the thing is that the more the number of teeth you have to create, right? So the cost also increases. The cost also increases, right? So if your cost is a concern, high power transmission or axial load is not a concern, then you can also use double helical gear, or even of lower cost you can use spur gear, right? You can also use spur gear. So herringbone gear, double helical gear, they are all the same. Non-parallel intersecting shafts. So what we are doing till now, are parallel shafts. What we are doing till now are parallel shafts. We are all talking about parallel shafts. What if the shafts which requires transmission, power trans, which requires transmission of power, right? Transfer of power are parallel, right? Now, if the shafts are non-parallel but intersecting, non-parallel intersecting shafts, so where will be the teeth formed? The teeth will be formed, right, on conical surface. The teeth will be formed on conical surface. As you can see, these are two cones. So we'll not use the whole cone, we'll just use a part of the cone, right? And what we are going to do, we are going to form teeth on the surface of the cone, right? So this kind of gears are known as bevel gears. The teeth are formed on cones. Now, bevel gears, again, they can be classified into straight bevel gear or spiral bevel gear. If the gear teeth are parallel to the axis of rotation. So suppose this is the axis of rotation and gear teeth are something like this. Right? Then it is known as straight bevel gear. For spiral bevel gear, the teeth will be inclined to the axis of rotation. That is spiral bevel gear, spiral or helical bevel gear, right? And then you have zero bevel gear. What is zero bevel gear? Suppose this is the shaft, and if the teeth are curved, right, a little bit curved, it is not just straight, slightly curved, right, then they are known as gerald bevel gears, right? They are known as gerald bevel gears. So questions might be asked, one mark questions can be asked, right? Then there is a special kind of gear which is known as mitre gears, right? So what are mitre gears? If you use two exactly same bevel gears with each other, then they are known as mitre gears. Two exactly same bevel gears. So these are two exactly same bevel gears, right? Connecting perpendicular shafts. Okay. So these are known as mitre gears. So what will be the velocity ratio of a mitre gear? If I say because both the gears are exactly same, so the velocity ratio will be 1. So power transmission means the two shafts, they will be perpendicular to each other. If you're using mitre gears, the two shafts will be perpendicular to each other, and the velocities of both the shafts will be equal. There is no change in the angular velocity. Omega 1 and omega 2 will be equal. Let me say this is omega 1. Let me say this is omega 2. In case of mitre gears, omega 1 is equal to omega 2. Or you can say angular velocity ratio is equal to 1. So this is all about intersecting shafts, non-parallel intersecting. So there can be non-parallel, non-intersecting shafts as well. Like this is one of the shaft, and the other shaft is something like this. Let me say it's not parallel, not intersecting, right? So in that case, what is going to happen? Okay, if you draw a perpendicular, this is how the perpendicular will look like. One shaft is on the top of the other. You can see one shaft is on the top of the other. This is how it looks like. So this is non-parallel, non-parallel and non-intersecting shafts. So peer rolling is not possible if the shafts are something like this. Peer rolling is not possible. So what is possible? Rolling plus sliding. So what is possible? Rolling plus sliding, right? Here the teeth will be formed on a hyperboloid, right? The teeth will be formed on a hyperboloid. On a hyperboloid, the teeth will be formed. For example, for bevel gears, where the teeth formed, teeth are formed on cone. For spur gears, helical gear, where are the teeth formed? The teeth are formed on the surface of a cylinder, right? Similarly, here the teeth will be formed on a hyperboloid. So what is a hyperboloid? If you use a skew line, okay? If you have a skew line, I wish I had the time to explain everything very nicely, but unfortunately, this is not gate preparation. It is. So if you have this kind of line, right? This is called a skew line. Okay, this is a skew line. If you rotate the skew line 360 degree or about this axis, right? What you're going to get is a surface which is known as hyperboloid. What you're going to get is a surface which is known as hyperbolic. So here you can see these are the two shafts. This will be one shaft and this will be one shaft, as you can see, right? So this type of gears are known as spiral gears. This type of gears are known as spiral gears. Now there is one more kind of gear that is known as worm and worm wheel. This is a very, very special gear, right? So this is the worm and this is the worm wheel. So they are also connecting perpendicular non-intersecting shafts. So this is one of the shaft and one of the shaft will go like this. So basically this is used for perpendicular non-intersecting. Perpendicular non-intersecting shafts. Perpendicular non-intersecting shafts. So what is the main USP of this? There are two USPs. Okay. Now here it is only the worm can drive the worm wheel. First USP. First USP is that only the worm can drive the worm wheel. Only worm can drive the worm wheel. Only worm can drive the worm wheel. Right? The worm wheel cannot drive the worm. This is the first USP. The second USP, which is even bigger, right? The speed ratio. The speed ratio can be achieved. Okay, is 50:1. Then with slight improvement, it went up to somewhere around 200:1. Then with more improvement, the speed ratio increased somewhere to 1250:1. Now it is even worm wheels with a speed ratio of 1250:1 is also possible. So this is a very, 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 very high speed ratio. The very, 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 very high speed ratio. This kind of speed ratio is generally not possible. Okay? It is only there are two types of gear systems. One is this combination of gear, worm and one worm wheel. The next is the epicyclic gear wheel, epicyclic gear train. That is not a combination of two gears, more than two. There's epicyclic gear train where you can achieve such kind of speed ratio. Otherwise, you will not have. So let us see why exactly. या फिर हम लोग गियर ट्रेन जब हम पढ़ेंगे ठीक है ना that time we'll see when you're going to study gear train in today's class we'll also see gear train that time we will try to see why is this kind of speed ratio not possible, right? So these are few ideas that I'm sharing, right? Then you have rack and pinion. What is rack and pinion, right? Here this is the pinion, pinion, pinion. This is the rack, so let me tell you one thing, when do we call a gear as a pinion? We call a gear as a pinion when in mating the one gear, the gear which is smaller in size is always called the pinion. What is the pinion now? This gear which is smaller in size. smaller size. So how exactly are we comparing which gear is bigger, which gear is smaller? That is through their diameters. So if two gears are in contact, the smaller one, that is the which who have a smaller diameter, right? So that will be the pinion. That will be the pinion. That will be the pinion. So here if you see, the rack is a gear of infinite pitch circle diameter. Infinite diameter. Rack is a gear of infinite dia. Infinite dia. So that is why definitely the rack is the bigger one and the pinion is the smaller one. So why exactly do we use rack and pinion? This arrangement is used to convert linear motion into circular motion and vice versa. Linear motion means the rack will move linearly to and fro. The rack will have a to and fro motion, linear motion, and what it will result in? It will result in the circular motion of the pinion, right? This is where, and vice versa, the circular motion of the pinion will also result in the to and fro linear motion of the rack, right? So this was the classification of gears with respect to the shafts, right? With respect to how the shafts are arranged, right? Now there can be classification of gears according to the type. Are they internal or external? If the teeth are formed on the outer side, just giving you a rough sketch, if the teeth are formed on the outer side, or ऐसे बना देते हैं, this will look a little bit good. If the teeth are formed on the outer side, then the gear is known as in external gear. If the teeth are formed on the inner side, it will be known as internal gear. The teeth can also be in inner side. The teeth can also be on the inner side. In that case, it will be known as internal gears. Right? Both have different applications. We will see in future. Right? So let us quickly go through the gear terminology. Let us quickly go through the gear terminology. Right? Let us quickly go through the gear terminology. Right? So Praveen, are you following? Good. So, have you gone through the previous classes, last two lectures? Hmm. Okay. So, I hope you. Okay, good, good. So, I hope you'll do it. Okay, you'll do it. Okay. So now we will go through the gear terminology. Like, what fast? Let us cover it up because we have a lot of things to cover. We are really short of time. We are really short of time. We have a lot of things to cover, right? So you can see this is a general. This is what you can see is a gear. Okay, this is what you can see is a gear, right? So this circle is known as the pitch circle. This circle you can see is the pitch circle. This circle is the pitch circle. Okay, so when two gears mash with each other, we are going to see it takes rolling happens about the pitch circle. Okay, rolling happens about the pitch circle. We'll see that. Okay, then this circle is known as addendum circle. The topmost circle is known as addendum circle, right? The bottommost circle is known as the dedendum circle. I've already marked it here. Root circle or dedendum circle. Okay, the first one is the addendum circle. Then you have clearance circle. Then you have this clearance circle. This circle is known as the clearance circle. The gap between the root circle or the dedendum circle and clearance circle, that is marked by 3. Point 3 is the tree. You can see here, I think I have written it here. Yes, it is clearance. What is tree? Tree is clearance. And what is the middle one? The circle in the middle one is the pitch circle. Middle one is a pitch circle. So this terminology is something important. Okay. So this distance, the first one is known as dedendum. Distance between pitch circle and dedendum circle is known as dedendum. The distance between pitch circle and addendum circle is known as addendum. This distance is addendum. Okay. Then the distance between clearance circle, this one, this point, the distance between clearance circle, and the dedendum circle is known as clearance. Okay. Then the total depth from the addendum circle to the dedendum circle is the tooth depth. From the addendum circle to the dedendum circle is the tooth depth, and tooth depth minus clearance, that is the distance between addendum circle and the clearance circle, is called the working depth. Okay. Now what is circular pitch? This distance is called circular pitch. If you go from here to here, let me mark it with dark blue. This is circular pitch. This distance is nothing else but circular pitch. The one marked with blue, you can see, the one marked with blue is circular pitch, right? The circular pitch can also be divided into two parts: tooth width and tooth gap. Tooth width and tooth gap. This again we'll see. Tooth width, right? Width of the tooth. How much is the width of the tooth and how much is the gap of the tooth, right? Okay. Now some important points to take care, and before that I'll just show you something. Okay, before that I'll just show you something. Suppose two gears are messing with each other. Right? So where pure rolling takes place is the pitch circle. The place where pure rolling takes place is the pitch circle, right? So gear tooth are not formed on those circles. So you will have dedendum circle will be below this. The dedendum circle will be below this. And addendum circle will be even. This is how the massing takes place actually. This is how massing takes place. So if you want to see a gear tooth, how exactly the gear tooth will look like, right? I'm just drawing one gear tooth. Okay. So it will start from here. It will start from here, somewhere here, and it will go up till here. And if you want to see gear tooth on the other teeth, on the other gear, it will look like something like this. Okay, let us not make the diagram very congested. Okay, this is one of the gear tooth. This is how the gear tooth will look like. Okay, I'm just giving a rough sketch. So you can see this is the dedendum circle. You can see this is the addendum circle, and you can see this is the base circle. Sorry, the pitch circle. So where exactly? This is a very common question that is being asked. Where is the pure rolling takes place? Where exactly the pure rolling takes place? So pure rolling motion is not taking place at the addendum circle nor at the dedendum circle. Where exactly it is taking place? It is taking place at. You can see where exactly is the rolling motion taking place, my dear? The rolling motion is taking place at the pitch circle. The rolling motion is taking place at the pitch circle, right? So the pitch circle, it is an imaginary circle in gear where pure rolling is observed when mating of the gears are transmitting power. When the mating gears are transmitting power, it is one of the biggest specification of the gear, and in fact, And in fact, right, the size of the gear is specified by its pitch circle diameter. The size of the gear is specified by its pitch circle diameter, right? The next point to discuss is circular pitch. What is a circular pitch? The circular pitch of a diameter is simply given by circular pitch. You have seen it in the diagram, right? So this distance is called the circular pitch. This distance is called the circular pitch, right? So how to find out the circular pitch? How to find out the circular pitch? It is very simple. It is equal to pi d by 2. That is circumference. What is pi d? Pi d is nothing else but circumference. Circumference divided by number of teeth. 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 What is it? It is nothing else but circumference divided by number of teeth. Circumference divided by number of teeth. Right? For two mating gears, the circular pitch should be equal. Okay, for two mating gears, the circular pitch should be equal. Only then they will be able to mate with each other and transmit power. Right? Now, what is module? What is module? Module is represented by m, right? Is again a very important specification of the gear, right? The ratio of diameter and teeth. It is a ratio of diameter and teeth. How did you come up with module? As you can see, for two mating gears, the circular pitch should be equal. So if two gears, 1 and 2 are mating with each other, the circular pitch of 1 should be equal to circular pitch of 2. So what I can say is pi d1 by t1 is equal to pi d2 by t2, right? So pi is a common term, we can cancel pi. Pi is a common term, we can cancel pi. Pi will get cancelled out. So I can say d1 by t1 is equal to d2 by t2. d1 by t1 is equal to d2 by t2. So what I can say d1 by t1 is equal to d2 by t2. So if you see this from here exactly, they said then why define circular pitch each and every time? Why to include the pi, right? Pi is again, a cannot get the exact value of pi all the time. So what to do? Right? So instead of that, we will use module directly. Now for two mating gears, the modules should be equal. Two mating gear, the modules should be equal. Yes, definitely for two mating gears, I can say module m1 should be equal to m2. So this is a very important parameter. Just hold on. Hello. Yes, sir. Okay. Just hold on. Okay, Praveen. Now you can see the screen. Okay, fantastic, right? So we were talking about pitch circle, circular pitch module. We are talking about pitch circle, circular pitch and module. So circular pitch circle is the uh, imaginary circle about which pure rolling is taking place. The size of the gear is specified by the pitch circle. Then circular pitch, we have seen it is a distance between two tooth, right? It is given by the circumference divided by number of teeth, that is pi d divided by t. Now for mating of two gears, the circular pitch of two gears should be equal. So circular pitch of 1 should be equal to circular pitch of 2. So if circular pitch of 1 equal to circular pitch of 2, we can say the pi will get cancelled out. d1 by t1 is equal to d2 by t2. And now the term d by t is defined as module. The term d by t is defined as module. So you can write module that is equal to d by t of two mating gears should be equal, right? So always remember for any solving of any questions with respect to gear, there's something very important. The module of two mating gears should be equal, right? Then you have something called diametral pitch. देखिए यहाँ से एक objective question आता है. That's why I'm taking this. What is diametral pitch? So diametral pitch is reciprocal of module, right? PD can be written as PD diametral pitch is T by D, that is reciprocal of module. So one question is being asked. What is being asked? What is the ratio of what is the multiplication of circular pitch and diametral pitch? If you multiply circular pitch and diametral pitch, right? PC into PD. So what is PC? PC can be written as pi d by t. And what is PD? Opposite of module 1 by m, that is t by d, right? It will get cancelled out, t and d will. So what will remain? What will remain is pi. Okay, this is question which is being asked, right? And there is a term which is known as backlash. What is backlash, right? Let us see again this diagram. ठीक है, इस diagram को एक बार देखते हैं फिर से. Let us see this diagram. What does this diagram say? ठीक है, so this is basically the tooth width. This is tooth width, and this can be said as tooth space or tooth gap. ठीक है, tooth gap. So when another tooth will come here, so the ठीक है, when another tooth will come here, right? So it should not get jammed. So it should not get jammed. So generally the tooth gap will be little bit more than tooth width. The tooth gap will be little bit more than tooth width, right? So tooth space minus tooth thickness is known as backlash, right? So what is backlash? Backlash is tooth space minus tooth thickness. So backlash is provided to avoid jamming of the teeth due to thermal expansion. Backlash is provided to avoid jamming of the teeth due to thermal expansion. Now let us understand some of the important parameters, important terms associated with gear, right? So when gears transfer power, let me tell you, when gears transfer power, let me say this is one of the gear, right? And then you have another gear. Let me say this is the other gear, or this is the other gear. Let me say this is the other gear. अच्छा नहीं बन रहा है, ठीक है, कोई बात नहीं. Let me say this is the other gear. It is not a very good diagram, but still I have to do it fast. So the line along which power is being transferred, the line along which the power is being transferred is known as line of action. Line of action. Always remember that the line of action will always be perpendicular to the two gears. Line of action will always be the perpendicular to the surface of the two gears. Perpendicular to the surface of two gears. Gear tooth to gear tooth, right? So that is why it is also known as common normal. It is also known as, since it is common to both the surface, common normal. That is also, it is known as common normal, right? So please remember this, line of action is always normal to the surface of the both the gear tooth, so it is called common normal, right? This is the straight line along which force is transmitted. Now there is a point which is known as pitch point. ठीक है, the point where the two pitch circles of the two mating gears touch each other is called pitch point. यहाँ दिखा देते हैं. Let me say this is one pitch circle, and this is one pitch circle. Let me say the gears are meeting with each other. Okay, so the point where this pitch circles are meeting, so pure rolling is taking place. This is the point where the two pitch circles are touching each other. So this point where the two pitch circles are touching each other is known as pitch point. This point is known as pitch point. Now what is pressure angle? Right? So let me again take this diagram. P पूरा नहीं चाहिए मेरे को, फिर भी Okay. Let me increase the size a bit. Okay. Now power is being transferred in which direction? The line of action will be somewhat like this. The line of action will look something like this. This is how the line of action will look like. The line of action will always pass through the pitch point. This is how the line of action will look like. Please remember, line of action will always pass through pitch point. This is law of gearing. Always passes through pitch point. Line of action always passes through pitch point. Okay. Now, the line of action means the force. Force is being transmitted along this direction. A force is being transmitted. A force will be along this direction. Now, this force can be now resolved into two parts, Fr and Ft. F can be resolved into two parts, Fr and Ft. What is the Fr? Fr is radial force. Fr is radial. Ft is tangential. Ft is tangential. So who is actually responsible for power transmission? The tangential force is responsible for power transmission, right? Power. Who will rotate? Is Fr going to rotate the gears or Ft going to rotate the gears? Ft is going to rotate the gears. So power transmission. Power transmission will be by Ft, right? So Ft is also a tangent. So if you draw the tangent, the angle formed between the line of action, or you can say F and Ft, is nothing else but the pressure angle phi. Pressure angle phi. Right? So can I say Ft is nothing else but F cos phi? F cos phi. Ft is F cos phi. So yes, it is actually F cos phi responsible for power transmission. It is actually F cos phi which is responsible for power transmission. Right? So these are some basic terminologies which are associated with the gear. Okay. Now let us see what exactly is law of gearing. Let us quickly understand what exactly is law of gearing. It says that to obtain a constant angular velocity, omega 1 by omega 2. See, gears are positive drives, right? We want constant angular velocities. We want constant angular velocities, right? We don't want this velocity, angular velocity, to change because of anything like slip, right? So to obtain a constant angular velocity, this is a basic requirement of a gear. Okay, this is a basic requirement of a gear. This is the basic requirement, very basic requirement of a gear. Basic requirement of a gear system. Okay, so to achieve this, okay, we can prove it through law of gearing, that the line of action should always pass through a fixed point. To achieve constant angular velocity, the line of action, that is a common normal, should always pass through a fixed point, and that fixed point is nothing else but the pitch point. That fixed point is nothing else but the pitch point on the line joining the center rotation. Definitely, pitch point lies on the line joining the center of rotation. This is one of the center of rotation. This is one of the center of rotation, pitch point, right? This is the pitch point. This is the pitch point. It lies on the line joining the center of rotation. Okay, this is the law of gearing, right? So all surfaces now, will all surfaces be able to provide satisfactory law of gearing? Will all surfaces, suppose, because we want teeth, right? So who will be mating? The teeth. The gear teeth will be mating with each other. The gear teeth will be mating with each other. This is one of the gear teeth. Let me say this is the opposite gear teeth, right? The gear teeth will be mating with each other. So if you want to make this surface, there is a profile. There's the profile of the gear. profile of the gear. If you want to make the profile of the gear, can any kind of surface will satisfy the law of gearing? Any kind of surface means, suppose I use parabola, suppose I use surface circle, or any general surface, right? Will it satisfy the law of gearing? No, right? Not all surfaces, not all profiles will satisfy law of gearing. The profiles which satisfy the law of gearings are called conjugate profiles. And there are only two conjugate profiles. What are the conjugate profiles? Involute profile and cyclodal profile. So this surface has to be either involute, the surfaces has to be either involute or cyclodal. The surfaces has to be either involute or cyclodal. Only then the law of gearing will be satisfied. Only then the law of gearing will be satisfied. So let us try to understand. Okay, we have involute profile in our syllabus. Okay, questions from cyclodal are not being asked. देखेंगे अगर time मिलेगा. If we get the time, then I'll try to explain the cyclodal also. So what exactly is involute? It is locus of a point on a line which rolls without slipping on a circle. So let me say this is a circle. Okay, let me say this is a circle. Now I shall draw a line on the circle. Let me draw a line on the circle. Okay, and on the line, let me consider a point. On the line, let me consider a point. Now, if I keep on rotating this line, like this, or let me say rolling this line on the circle without rolling this line on the circle without slipping. So you can see this line is rolling on the circle without slipping. You can see this line is rolling on the circle without slipping, right? This line is rolling on the line without slipping. The locus of a point, let me say this is the point A. The locus of this point, the path traced by the point is nothing else but involute profile. Okay, let us start analysis. We'll not be able to do a whole analysis. बहुत सारी चीजें रहती है, ठीक है? It takes almost 1.5 hours to do the analysis, but I'll try to show you something. Right? So the engagement starts here and the engagement ends here. This is known as KL, let me say. Okay, so here you can see it starts here, where when the addendum, एक बार यहाँ explain कर देता हूँ. Let me explain it to here itself. ठीक है? What is this? This is pitch circle. This is, let me say, gear number 1. This is gear number 2. These are two mating gears. We have already seen this is the pitch circle of 1. This is the pitch circle of 2. Right? So this is the pitch point. Right? Here you can see this is, this is the line of action. This is the line of action. If you want a common tangent, this is how the common tangent will look like. Okay, so this angle, you can see this is nothing else but pressure angle phi, right? So if you see, okay, this is the addendum. You can see two addendums. This is addendum circle of gear 1. This is the addendum circle of gear 2, right? So when will the contact between two surfaces begin, right? It is when you can see this addendum of gear 1 will touch the tooth of gear 2. When the tooth of gear 2 is touched by the addendum of gear 1, right, that is when the contact between the two will begin. This is where. This is where the contact between the two will begin. Right? And when will the contact end? When the contact will end when the addendum of gear 2, right? When the addendum of gear 2, A2 is touching the gear tooth of 1, the gear tooth of gear 1, right? That is when the that is the last point of contact. That is the last point of contact. So this is this point. So contact has taken place from here to here. The contact has taken place from here to here. So this is known as path of contact. What is this known as? This is known as path of contact. Path of contact. This is known as path of contact. This is known as path of contact. Okay, so generally equations होते हैं, we derived equations for part of contact, what is the value of part of contact, how to find it out, all those things for classes in GATE, but that is not necessary. That will not be necessary for this class. Okay, so now why we are doing this? Because we want to understand something known as contact ratio. Questions can be asked from contact ratio, right? So what is arc of contact? Arc of contact can be given as arc of arc of contact. Arc of contact can be given as path of contact, path of contact divided by cos phi, divided by cos phi, where phi is nothing else but pressure angle. Where phi is nothing else but pressure angle, right? So you can see here, this is the arc of contact along the pitch circle. This is the arc of contact. This is the arc of contact. This is the arc of contact. Okay, are you following, Praveen? Okay, great. So I hope you are able to cope up, right? I know speed is fast. I know explanation is on the lower slide, but I really want to cover up all the points which have the maximum chances of being asked in your exam, right? Because we have to cover it up in the least possible time. Okay. So there is a term which is known as contact ratio. There is a term which is known as contact ratio. What is a contact ratio? What is contact ratio? So contact ratio is, it gives us the information about the number of pairs the tooth engaged during the engagement period, right? So now contact ratio, first let us see how to define the contact ratio, right? So contact ratio is equal to arc of contact divided by circular pitch. Contact ratio is equal to arc of contact divided by circular pitch. So what exactly is contact ratio? Right? So suppose you have a contact ratio of 1.12. Suppose you have a contact ratio of 1.12, right? So what does it mean? It means that during the full engage during the mating of the gear, right? At least one pair of the teeth is engaged full time. One pair is engaged in full engagement period, and for 21% of the time, two pairs of teeth are engaged. Right? It is not necessary that only one pair of teeth remain in contact at a time. Right? It depends on how the gears are constructed. What is the module? what is the height and thickness of the gear tooth, right? So it depends on lot many things. So what does contact ratio say? Contact ratio says us at a particular time, okay, how many percentage of time one pair of teeth are in contact, how many percentage of time two pair of teeth are contact, how many percentage are more than two teeth, right? For example, suppose I have a contact ratio of, say, let me say 2.3. Let me say the contact ratio is 2.3. So what does it mean? It means that 100% of the time, 100% of the times two pairs are in contact, and 30% of the time three pairs are in contact. Okay, so now contact ratio, it cannot be less than 1. The minimum value of contact ratio is 1. Why? Because if it becomes less than 1, it means that 100% of time even one pair is not in contact, so it is not possible to transfer power that way. It is not possible to transfer power that way. Okay, so I request you to go through once whatever you have studied. This is all about gears. Now we'll enter into gear trains. We have another 45 minutes, right? We'll complete gear trains in that, right? So just go through once whatever you give me in 2 minutes, and ask me any doubt, Praveen, if you have. Fast. In 2 minutes, just go through whatever and ask me any doubt if you have. Otherwise, we'll enter into gear train. Okay, so we'll go ahead. Is my voice clear, Praveen? Is my voice clear? Is my okay? Fine. So we'll start gear trains. Okay. So what exactly are gear trains? Right? Gear trains are actually combination of more than two gears. Generally, if two gears are in contact, we'll simply say gears are mating. Two gears are mating. If the combination of gears are more than two gears, then we say them. Then we call them gear trains. Right? Why the name trains? Trains. You can imagine because of one gear after the other. We are going to see. Right? So why exactly are gear trains used? For two purposes, basically, to meet large center distance and to meet high or very low velocity ratios. So if the center distance are very large, if the center distance between the shafts are very large, right? So instead of using very large gears, what we are going to do, we are going to use gear trains, because large gears will you have the problem of inertia, right? The large gears will have problem of inertia. Initial torque required to start those gears will be very high, and it will not give you a very good efficiency in terms of power transmission. A lot of power will be lost in friction and heat, right? And secondly, if you see, if you require very high velocities ratio, I told you during warm and warm wheel time, right? Warm and warm wheel pair can achieve a very high velocity ratio, which is not feasible otherwise. So why is this a very big USP for the warm and warm wheel? That is why, because if you imagine, suppose omega 1 by omega 2 is equal to, let me say 10. So omega 1 is equal to 10 times omega 2, right? Or in other words, we have previously seen that omega 1 by omega 2 is equal to R2 by R1. That is radius of the second wheel, second gear divided by radius of first gear, right? From this, we can say that the R1 or sorry, R2 will be 10 times R1. So you can just imagine the size of the two gears. Just you can imagine the size of the two gears. The radius of the second gear is 10 times the radius of the first gear. So if the first gear looks something like this, so 10 times the radius, if you see, if you figure it out, times how big will the 10 times the radius look like? If you think this is not 10 times the radius, 10 times the radius will be looking like this. So you can imagine this gear combination is definitely not going to work. The pinion is very, very small to drive the gear. The pinion is very, very small to drive the gear. So in case of high velocity ratios, right, what we have to do is you have to use gear trains. What you have to do is you have to use gear trains. Otherwise, there is an option. What option is there? For very, very high velocity ratios, for very, very high velocity ratios, okay, I will get into FX. Just hold on, guys. Just hold on, hold on, hold on, hold on. Just hold on. Okay. Okay. So he's in now. Interesting. So you can hear me. Is my screen visible to you? Okay, fantastic. So, as I said, it is very difficult for the pinion to drive. It is not difficult, it is almost nearly impossible for the pinion to drive the gear, right? So, in that case, we will not be able to have a very high velocity ratios, right? So, either you have to use a worm and worm wheel, and again, worm and worm wheel, we cannot use this for all different purposes, right? It is only the worm can drive the worm wheel, first of all, and the second point is that the shafts should be perpendicular, not intersecting. So if those conditions are not met, what we are going to do, we are going to use gear trains. We're going to use gear trains. So let us first understand there are a few terms and terminologies which you have to understand. There will be the main driver, there will be main driven, and apart from this main driver and main driven, right, apart from the driver and driven, there will be intermediate or idler gears. We have to identify which are the main driver. The one who is driving the system will be the driver. The one who is getting driven is the driven, right? And all other gears will be intermediate or idler gears. We're going to see, right? Then there is a term which is known as speed ratio. There is a term which is known as speed ratio. The speed ratio is divided by angular velocity of main driven by the angular velocity of main driver divided by angular velocity of main driven. Okay, the speed ratio is angular velocity of main driver by angular velocity of main driven, right? So generally I'll tell you, okay, generally if you use gear and gear, this is suppose I'm just using two gears here, right? So the smaller one is the pinion, the smaller one is the pinion, and the larger one will talk as gear. Okay, the smaller one will be numbered as 1. Pinion is generally numbered as 1 and gear is numbered as 2, and pinion is actually the driver generally, right? And gear is the driven one. Gear is the driven one. Okay, so please remember this, right? To angular velocity of main driver by main driven, it can be written as omega 1 by omega 2. It can be written as omega 1 by omega 2, right? Then there is a term called train value. There is a term called train value. What exactly is train value? Train value is 1 upon speed ratio. Train value is 1 upon speed ratio. And all of you need to remember this. Okay, I'll not go into very much detail. Okay, this is can go. It is very easy because module of two gears has to be equal, right? Module, what is module, my dear? What is module? Module kya hai? What is module? Module of gear 1 should be is equal to module of gear 2. From this you can derive this, right? Omega 2 by omega 1 is equal to d1 by d2 is equal to d1 by d2, right? This is very important with respect to gear trains. This is very important with respect to gear trains. So let us enter. So the first what we are going to see is simple gear trains. First we are going to see is simple gear trains. First what we are going to see is simple gear trains, right? Now every shaft is having only one gear in use. Module of all the gears will be same. So module 1 is equal to module 2. लिखा हुआ है क्या? Yes, it is already written. I will not rewrite it. Module 1 is equal to module 2 is equal to module 3 is equal to module 4. Right? So this is the main driver and this is the main driven. All other in between gears are intermediate gears. 2 and 3 are intermediate gears. 2 and 3 are intermediate gears. 2 and 3 are intermediate gears. So what exactly is happening here? 1 is driving 2, then 2 is driving 3, 3 is driving 4. That is what happening. That is how it is happening, right? Now there is something to learn here. If the number of idlers is odd, okay, if the number of idlers is odd in number, then the rotation of the main driver and main driven will be same. If the number of idlers is even, directional rotation of main driver and driven will be opposite. Let me see. Let me check here. Okay. Suppose this is clockwise. So two gears in contact. If the one is clockwise, the other will be, the next one will be anti-clockwise. If it is rotating this way, this will rotate this way, right? So the first one is clockwise, then the second one will be anti-clockwise. The next one, if this is anti-clockwise, the next one will be clockwise. If this is clockwise, the next one will be anti-clockwise. So you see, if the number of gears idlers is even, here the number of idlers is even, 2 and 3. You get 2 and 3 are idlers, 2 comma 3 are idlers, right? Direction and rotation of main driver and driven will be opposite. So if the main driver is clockwise, the main driven is anti-clockwise. And similarly, if the number of idlers is odd, the direction and rotation of main driver and main driven will be same. Okay, so now how to solve? What kind of question will be asked here, right? You might be given the speed of the gear 1 and you might be asked speed of gear 2, 4. You might be given speed of gear 1, you might be asked speed of gear 4, right? So let us directly do a problem and try to understand it. Okay, instead of forming equation here, let us directly try to do a problem and understand it. Okay, this kind of a gear. Okay, this is kind of a gear. So see, you can see clearly, see P is connected to Q and Q is connected to S, right? Here gear R is not neither connected to P nor connected to S. So you can simply ignore gear R. You can simply ignore gear R. So let us do this problem fast. Okay. So what is given? Let us see. There are 4 gears P, Q, R, S, no doubt, but only 3 are engaged. P, Q, and S are engaged, right? Gear R on mounted on the same shaft. Okay. Gear Q and R are mounted on the same shaft. All the gears are mounted on parallel shafts. The number of teeth on PQR are 24, 45, 30, and 80. 24, 45, 80. This is what we require. This is what you require. Just hold on. Speaking continuously for 2 hours is also a task. Non-stop. So a gear train shown in the figure, okay, teeth are given. Gear P is rotating at 400 RPM. So what is the N? The rotation of gear P is equal to 400 RPM. Very easy, right? The speed of the gear S is, the speed of the gear is being asked. Okay, so very easy to do. Okay, just remember this formula. First formula ये remember करेंगे, or I'll write it down for you. No issue. कहाँ गया इसी फॉर्मूले से सारा क्वेश्चन सॉल्व हो जाएगा. ठीक है, राइट रीराइट दिस फॉर्मूला अगेन एंड अगेन एंड अगेन एंड अगेन. ओमेगा 1 by omega 2, in place of omega I can also write n, no issue, is equal to omega 2 by omega 1 is equal to d1 by d2 is equal to t1 by t2. यही है formula, ठीक है, for all the gear trains. Rest are easy, rest are easy. If you know this, then there is not much problem. ठीक है, देखते हैं how to solve it then. ये सब आएगा. Okay, now what is omega? Can I say omega is equal to 2 pi n by 60, right? So in place of omega 1 by omega 2, I can also write n1 by n2. There is no problem. So np by nq. First, I will go from P to Q. First, I'll go from P to Q, then I'll go from Q to S. So NP by NQ can be written as, in terms of teeth, if you want to write in terms of teeth, it will become TQ by TP. It will become TQ by TP. Okay, let me say this is equation number 1. Okay, now NQ by NS, that is we are going from Q to S. Now we are going from Q to S. NQ by NS can be written as, in terms of number of teeth, it can be written as number of teeth on S divided by number of teeth on Q. So if you simply multiply 1 and 2, what you're going to happen is NP by NQ multiplied by NQ multiplied by NS is equal to TQ by TP into TS by TQ, right? Few things are getting cancelled, as you can see. Let us very swiftly cancel these things, right? So what is the value of NS now? NS is equal to, cancel हो गया, NS is equal to NP into NS, sorry, TP by TS, right? NS is equal to NP TP by TS, that is equal to 400 multiplied, what is TP? Number of teeth on P is 24, number of teeth on P is 24, and number of teeth on S now is 80. 80 into 5s of 400, right? And 24 into 5 is 120. So what is the speed of NS? That is 120 RPM. Now if it is asked clockwise or anti-clockwise, if this is clockwise, this will be anti-clockwise, then this will be clockwise. Means direction will be same. The direction of NP and NS will be same. So is it clear? Were you able to follow? Fast here, no doubt, but very easy problem, isn't it? And this has been asked in GATE. This has been asked in GATE. Is it clear? Fantastic, fantastic. Let us now move on. So this was simple gear train. Okay, this was simple gear train. Okay, this was simple gear train. So in simple gear train, what exactly is happening is, mainly one shaft has one gear. Here it is already, I have written it. Okay, every shaft is having only one gear in use. Every shaft is having only one gear in use, right? Means there are no two gears on single shaft. No two gears being used on single shaft. ठीक है, अभी यहाँ पर confusion आ सकता है, ठीक है? That confusion I will clear it after compound gear trains, ठीक है ना? I'll clear, you might have a confusion, I'll clear it after compound gear trains. So what is compound gear trains? Compound gear trains, right? They can have, means at least one of the intermediate shafts has more than one gear installed and in use. Not just installed, it is also in use. It's not just installed. At least one of the intermediate shaft, right, has more than one gears installed and also in use. Intermediate means it is not talking about the main driver and main driven. Apart from main driver and driven, whatever the shafts are there, they will be known as intermediate shafts. They should be in use, right? Means they should have more than one gears and they should be in use, right? So here you can see one is the main driver. So one is driving two. As you can see, one is driving two. 2 and 3 are on the same shaft. 2 and 3 are on the same shaft. So 3 is driving 4. 4 and 5 are on the same shaft. So if 2 and 3 are on the same shaft, so what is happening? If 2 is rotating, the shaft will rotate. If the shaft will rotate, 3 will also rotate. That is what is happening. 1 is driving 2, so 2 will rotate. If 2 rotates, the shaft in which 2 is attached will also rotate. So if the shaft in which 2 is rotates, in that shaft there is also one more gear, that is 3. So 3 will also have to rotate. So if 3 rotates, 3 will drive gear 4. If 3 rotates, 3 will drive gear 4. And now if gear 4 rotates, the shaft on which gear 4 is mounted will rotate. And if the shaft on which gear 4 is mounted, if it rotates, definitely what is going to happen is gear 5 will rotate, right? Because gear 5 is all and gear 4 are on the same shaft. And if 5 rotates, it will 5 will actually rotate gear 6. 5 will actually rotate gear 6, right? So either 1 is the main driver and 6 is the main driven, and apart from that there are intermediate drivers also. For example, 3 is driving 4, so 3 also becomes a driver. 5 is driving 6, so 5 also becomes a driver. So 2 is being driven by 1, so 2 is a driven. 4 is driven by 3, so 4 is also driven. 6 is driven by 5, so 6 is also driven. So there are 6 driven gears. 1, 3, and 5 are driver gears. 2, 4, and 6 are driven gears, right? And there are no intermediate gears. There are no intermediate gears. We'll talk about intermediate gears again. Okay? We'll talk about intermediate gears again. Okay? Before that, let us first complete this compound gear tree, right? So if you want to form the equations, कैसे form करेंगे? How exactly we are going to form the equations? देखते हैं. How exactly we are going to form the equations? ठीक है? Here, please remember, here all the modules were equal, 1, 2, 3, 4, because 1 is in contact with 2, so 1 and 2, module of 1 and 2 will be equal. 2 is in contact with 3, so module of 2 and 3 is equal. 3 is in contact with 4, so module of 3 and 4 are equal. So I can say that all the modules, module 1, module 2, module 3, module 4 should be equal. In compound gear trains, 1 and 2 are mating, so module of 1 equal to module of 2. 3 and 4 are mating, so module of 3 is equal to module of 4. 4 and 6, 5 and 6 are mating, so module of 5 is equal to module of 6. ठीक है, देखते हैं थोड़ा सा if something is possible. Let me copy. Let me try to paste it. नहीं आ रहा है. I don't know why. It's not coming because it is in PDF format. That's why. No issue. Now we will try to form it here itself. We'll try to form the equations here itself. यहीं पर try करेंगे. We'll try to form the equations here itself. ठीक है. So let us see. ठीक है. If I want to write omega 1 by omega 2. If I want to write omega 1 by omega 2, right? Can I say this is equal to T2 by T1? This will become equation number 1. Omega 1 by omega 2 is equal to T2 by T1. Similarly, if I write about 3 and 4, I can write omega 3 by omega 4 is equal to T4 by T3. This equation number 2. Omega 5 by omega 6, can I write it as T6 by T5? This equation number 3. So if I multiply 1, 2, and 3, I think I'll be able to complete copy it. Copy, paste, yes. So if I multiply 1, 2, and 3, now if I multiply equation 1 into equation 2 into equation 3, this implies omega 1 by omega 2 into omega 3 by omega 4 into omega 5 by omega 6 is equal to multiplication of T2 into T4 into T6. थोड़ा हैंडराइटिंग अच्छा कर लो, थोड़ा सा हैंडराइटिंग अच्छा कर लो प्लीज. ओके, T2 multiplied by T4 into T6 divided by T1 into T3 into T5, right? So अभी देखिए एक चीज very important thing here, right? Can I say omega? Can I say here that omega 2 is equal to omega 3? Why? Because they are mounted on the same shaft, right? Similarly, can I say omega 5 is equal to omega 4? Why? Because 4 and 5 are mounted on the same shaft, so I can cancel these terms, right? 3 and 2 will get cancelled out, 5 and 4 will get cancelled out, so what is left behind is omega 1 by omega 2, that is the speed ratio, right? Speed ratio is equal to T2 into T4 into T6. And do you know what exactly is T2, T4, T6? Can I say 2, 4, 6 are driven? So number of teeth on driven gear, number of teeth on driven divided by T135. What are 135? 135 are driver, number of teeth on driver. Number of teeth on driver. Number of teeth on driver. This is how you're going to solve it, ठीक है? But probability of this being asked is little bit less, ठीक है? लेकिन हाँ, numerical ऐसे simple numerical बन सकता है. You should be able to answer, right? Now, important concept here. Important concept I'll deliver with respect to idler gears. With respect to idler gears, how to identify the idler gears? How to identify the idler gears? बहुत simple सा concept है, लेकिन बहुत important concept है. Simple concept but important concept, ठीक है? Okay, so any gears, if they are connected to two other gears, for example, if you see gear 2, it is taking power from 1 and it is delivering the power to 3. It is taking power from 1 and it is delivering the power to 3. So basically gear 2 is not contributing to anything. Even if you want to see the speed ratio, okay, even if you want to see the speed ratio here, चलो देखेंगे देखेंगे, ठीक है ना? Even if you want to देखेंगे, we'll go back to that slide, ठीक है? So then that gear will be called as idler gear, ठीक है? I'm giving a shortcut hint how to find out idler gears. If a gear is connected to two other gears, then it will be known as idler gears. For example, 2 is connected to 1 and 3, so 2 is idler. So 3 is connected to 2 and 4, that means the 3 is idler. So idler gears does not contribute to power transmission, ठीक है? Does not contribute in power transmission. Power transmission and in speed ratio. And in speed ratio. I'll show you this. The formula, we have done one question, right? I'll show you that the idler gear does not contribute in the speed ratio as well. Does not contribute in the speed ratio and power transmission as well. That is why they are known as idle. It is here known as idle. So what is their function then? Their just function is to fill the gap. Their function is to fill the gap, right? So how to identify an idle gear? If it is connected to two other gears, it is taking power from one and it is delivering to the other, then it is known as idle gear. So let us do this question. Equation करते हैं, ठीक है? Where again you've been asked to find out the idler gears. Yes, this is so. A gear train is made up of 5 gears per gears, as shown in the figure. Gear 2 is a driver, okay, and gear 6 is driven by the member, and 2 3 4 5 6 represent number of gear teeth. Okay, the gears which acts as idler is, which gear acts as idler here? कौन सा gear idler है? How to see? So I have to find out gears which are connected to two different gears, right? So driver or driven to idler होगा नहीं, ठीक है? If you see gear N 3, right, it is connected to 2 only. The other side is not connected to anything, right? So 3 is not an idler. If you see 4, 4 is connected to 5 only, means it is a driven, in fact, right? So it is also not an idler. But if you see 5, if you see gear number 5, if you see gear number 5, right, it is connected to two sides, it is connected to 4, and it is also connected to 6. So what is gear 5 doing? It is taking power from 4 and it is delivering to 6. So what is gear 5? Gear 5 is idler. Gear 5 is idler. So this is again a question from gate, if asked in gate. Okay. Now this is one of the questions we have done. Okay. Now here you can see gear Q and R are mounted on the same shaft, but still this is not a compound gear train, it is a simple gear train. It's not a compound gear train, but it's a simple gear train. Why so? Because though gear R is mounted on the shaft where gear Q is also mounted, but gear R is not in use. Is gear R being used? No. It is neither connected to P nor connected to S. Use in or so just leave behind gear R, right? That is why it is a simple gear train. It is not a compound gear train, right? If gear R was used, for example, in place of S was not connected to Q. Let us suppose S, instead of connecting to Q, suppose S got connected to what? R. Then in that case, it would have been a, in that case, suppose it was like this. Instead of Q, suppose S was connected to what? R, right? Then definitely you would have said that this is a compound gear train. But here, if you see, gear R is not in use. So it is not a compound gear train. It is a simple gear train, right? Now, if you see about Q, if you see Q, if you see Q, Q is an idler gear. Why? It is taking power from, it is taking power from P and it is delivering the power to S. So what is Q? Q is an idler gear. So that is why even in the speed ratio, you see the speed of Q is getting cancelled. Number of teeth on Q is getting cancelled, isn't it? Isn't it? Speed of Q, the speed of Q, sorry, the speed of Q is getting cancelled. The number of teeth on Q is getting cancelled, right? That means it is not contributing to the speed ratio, right? The idler gear is not contributing to the speed ratio. Okay, idler gears से questions probable है, right? The questions might be asked from idler gears. Questions might be asked from idler gears. I hope this is clear. I hope this is clear. ठीक है, क्वेश्चन ये कर सकते हैं, no doubt. ठीक है, let us do this question. Let us do this question. ठीक है, this is again a good question, and this is a compound gear train. This is a compound gear train. P is connected to Q, right? And Q and R, they are mounted on the same shaft. R is connected to S, right? But this is not a question from gear train. Instead, this is a question from, I've taken it from, this is normal. You can say, though this is a gear train, not, this question is not about speed ratio. Instead, this question is about center distance. This question is about center distance. Let us attempt this question. Okay. A compound gear train with gears PQRS has number of teeth 20. P में कितने teeth है? 20. Q has 40, R has 15, and S has 20 teeth respectively. Gears Q and R are mounted on the same shaft as shown in the figure below. Okay, the gear diameter of gear Q is given, diameter of gear Q is equal to twice that of gear R, twice the diameter of gear R. If the module of gear R is 2, if the module of gear R is 2, M of R, module of R is say 2 meter, the center distance between the gear P and S is. So this center distance is being asked. This is the center distance. So can I say center distance is equal to radius of P plus radius of, I'll show you how. ठीक है, देखते हैं. Radius of P इतना हो गया. Red one is radius of P. Then radius of Q, that is the green one. You have to find out the center distance. You need to find out the center distance, right? Center distance is equal to, right? The first one is the radius of P plus, then you have radius of Q plus, Then you can say you have radius of the small gear, that is कौन सा है, r. This is radius of r, radius of r, plus the last gear, that is radius of s, radius of s. So basically you need to find out the radius of r, p, q, r, s, radius of p, q, r, s, right? So देखते हैं, let us find out, try to find out, right? So radius, what is the data given? Data given is the number of teeth, diameter of a module of gear r, module of gear r is given. So can I directly find out the uh, diameter of gear r? So I know module is equal to diameter divided by number of teeth. So module of gear r is 2, that is equal to diameter of gear r divided by teeth on gear r. So what is the teeth on gear r? Teeth on gear r is 15. So I can say diameter of gear r is equal to 30. Diameter of gear r is 30, right? So once I know the diameter of gear r, I can say diameter of gear q, diameter of gear q is equal to 2 times diameter of gear r, that is equal to 2 into 30, or I can say diameter of gear q is equal to 60, right? So दो diameter तो मिल गए, which one? Q and R. So now I need to find out the diameters of R and P, diameters of R and P, right? What is the diameter of R and P? So how to find out the diameter of, sorry, not R and P, P and S, right? Now R is in mesh with S. So can I say module of R is equal to module of S? Module of R is equal to module of S. So from this equation, right, because R is in mesh with S, right? So module of R is equal to module of S, right? So module of S, what is module of S? Becomes 20 is equal to diameter of S divided by number of teeth on S, that is 20. So diameter of S is equal to 2 into 20, that is 40, right? So now I need to find out the diameter of P. How to find out diameter of P? For that, if I can get module of P, it will be very good. So now module of Q is equal to module of P, I can say it is equal to module of Q because P and Q are mating with each other. What is module of Q? Can I say module of Q is diameter of Q by number of teeth on Q? So module of P is equal to module of Q is equal to, what is diameter of Q? I have already found out 60. Teeth on Q is 40. So 60 by 40, that is equal to 1.5, right? So module of P is equal to 1.5, right? So if module of P is equal to 1.5, so what is the diameter of P? Diameter of P is equal to module by number of teeth, 1.5 into 20, that is 30. That is equal to 30. So what is the radius center distance then? Center distance can be said radius of all the gears, sum of radius of all the gears. So you can say 30 plus 60 plus 40 plus 30 divided by 2. So 60 plus 40 is 100, 130, 160 divided by 2. So answer will be 80. Answer will be B, 80. So I hope you got it. So this kind of problem also you should be able to attempt. This kind of problems also you should be able to attempt. So I'm showing you all different problems, not all different problems, whatever is feasible, whatever can be asked. So is it clear, Praveen? I know I'm going very fast. I know I'm going fast, undoubtedly fast, right? So otherwise we will also do lot many questions in gate classes. I am also feeling, I don't know if only those students who have already done these things before, studied before, right, they will be able to understand it at a speed like this, undoubtedly. Okay, two more types of gear trains we'll see, that is reverted gear trains and epicyclic gear trains, right? So reverted gear trains are used to connect coaxial shafts. Coaxial shafts. So this is suppose the input shaft or the driving shaft. This is the input shaft and this is the output shaft. Right? You can see the input shaft and the output shaft are coaxial. 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 The input shaft and the output shaft are coaxial. Right? They are along the same line. They are along the same line. Right? So if you want to connect shafts like this, right, using some gear trains, and what kind of gear trains we are going to use is reverted gear trains. How exactly देख लेते हैं, जल्दी जल्दी fast देख लेते हैं how exactly we are going to connect using gear trains. So this is one gear. So to connect it to this gear is this gear, right? So from here you can see these two gears are mounted on the same shaft. If these two gears are mounted on the same shaft, this is again another gear, and this is a gear, and this is the other gear. This is the other gear, right? Just hold on. Okay, right? So basically, two questions can be asked from here. Okay. If you see rotation, three questions. Okay, fine. Okay. So where are reverted gear trains used? It is used. It is a compound gear train which is used for transferring power to coaxial shaft. So what is the rotation? If you say this is this is clockwise. If I say this is clockwise, so this will be anti-clockwise. Now these two are the same shaft, so this is anti-clockwise, right? And this will be clockwise. So the sense of rotation of the input and output shaft will be same. Sense of rotation of input and output shaft will be same. And a simple example where reverted gear train is being used, right? That is our watch or clock. So our watch or clock, you see, there are three hands, right? The hour hand, minute hand, and the second hand. The hour hand, the minute hand, and the second hand. All the three shafts are connected through the same shaft. All the trees, all the three hands are connected through the same shaft. That is using reverted gear train, right? So all have there is a particular angular velocity, right? All different. The angular velocity of all the shafts will be constant, right? The ratio of angular velocities of the second hand and hour hand and the minutes hand will be constant. That is what gears are used inside, and what kind of gears are used? Gear trains. So three questions possible from here, right? So next is epicyclic gear train. Next is epicyclic gear trains. Again, this is very useful. It is used in lot many places. Epicyclic gear trains is used in lot many places, right? And in aerospace industries, even in vehicles, in rockets, it is used in so very wide applications. Epicyclic gear trains have so very wide applications, right? Okay, let us try to understand what exactly is epicyclic gear train, right? So epicyclic gear train is a gear train, right, in which apart from the rotation of the gears, if any gear is rotating to some other axis, for example, in this, let us consider this is a gear, let me say 1, and let me say this is gear 2, and there is one connecting arm. This is one connecting arm, right? Let me say all the gears are rotating. Okay, all the gears are rotating, and apart from rotation of this gear, okay, this is also rotating, this is also rotating. Apart from rotation of the gear, what is happening? What is happening is this gear is rotating, also rotating around the larger gear. So you can see the smaller gear is gear number 1 is also rotating, is also rotating, is also rotating, is also rotating about the smaller gear, like this, something like this, something like this, something like this. The arm is come here, then it will come here after some time, then it will come here. The arm will come along with it, no doubt, undoubtedly. Arm will come along with it. So this is what is happening. So gear number one is also rotating with along the gear number two. So apart from rotation of the gears, the gear is also rotating with respect to some other gear. So in this case, you know it as epicyclic gear train. इसमें अच्छे numericals बनते हैं, but these numericals are out of scope for this exam. Numericals are out of scope for this exam, but it's a favorite topic for GATE. Lot many questions on numericals. General numericals are being asked from epicyclic gear trains, right? So now they have particular term. I'll show you one more diagram of gear train. So here you can see the one which is rotating is known as the planet gear. Planet gear. The one which is rotating is known as the planet gear. The one in the middle is known as the sun gear. Okay? And this is the arm. This is the arm. Planet gear, arm, and sun gear. Planet gear, arm, and sun gear. Planet gear, arm, and sun gear. Right? I'll also show you one more diagram. Okay? And one more. This is sun gear in the middle. There can be more than one planet gear, in fact. There can be more than one planet gear. It is not necessary that there is only one planet gear. Generally, we might also use 3 planet gears like this, and then there is an annular gear, and then there is an annular gear like this. Something like this. Something like this. Okay. So these are all. The inside gear is a different color. This is the arm. The green color is the arm, right? The green color is the arm. The smaller gears are the planet gears. The inside one is the sun gear, and the outside one is also known as the ring or annular gear. Inside one is known as the ring or annular gear, right? So इसमें numerical तो मुश्किल है because numerical takes at least 2-3 minutes to solve. It is not very easy, but yes, definitely you can be asked about um, the epicyclic gear trains, right? So where are uh, various places epicyclic gear trains are used, right? And it is used for high speed ratio. One frequently asked question is high speed ratio. High speed ratio. High speed ratio. It is used for high speed ratio, right? So yes, we have done 3 numericals, kind of, okay, 3 numericals, and we have done fair amount of theory in a lecture of 1 hour. Yes, I understand not everything was possible to be covered. I have tried to given you the maximum amount of information in the 2 hours. I tried to give you the maximum amount of information in this 2 hours, right? So I hope you have enjoyed the lecture. I hope you have enjoyed the lecture. So tell me if you have any doubt. So in 2 hours, we have done 38 pages. In 2 hours, we have done 38 pages. 38 slides. Okay, thank you. That's all for gears, right? So tomorrow we'll have another chapter that is, yes, dynamic analysis of slide effect mechanism flywheels and governors. Thank you. Thank you.